Hi there, and welcome to this EduConnect video. So this video is a bit of an extension on the video relating to indices. So first of all, this is mainly about prime decomposition and LCMs and HCFs and that sort of stuff. So the first thing we're going to look at is what exactly a prime number is. So a number is defined as prime if it has no other factors than itself and 1. So an example of a prime number would be 2 or 3 or 5. Because the factors of 2, for example, are 1 and 2. For 3 is 1 and 3, and for 5 is 1 and 5. Now, a lot of people think that the number 1 is a prime number. Now, it is not, because the definition of prime number is that it has 2 factors. One factor is not a prime number, so therefore 1 is not a prime number. Now, when it comes to decomposition, all that means is basically finding the prime factors of a number. Now, this is very useful in many scenarios. So, the prime factor of a number, so say we have a number like 10. Obviously, the prime factors of this number would be 2 times 5. Or say 20. That would be 4 times 5. Now, from the previous video, we know that 4 is 2 squared. So the prime decomposition is 2 squared times 5. So the way we do this, there's a couple of methods. The method I like to use is the tree method. So what that is you get your number up here. So say we start with a big number like 92. Alright? And now you break it down. So the first layer is pretty obvious. It's an even number, so you can divide it by 2. So 92 divided by 2 would be 46. Now you can divide that again by 2, and you'll get 23. Now 23 is a prime number. So essentially now you have your prime numbers, which are your branches of your tree, essentially. So what this is, there's 2 2's, so that means it's 2 squared times 23. That's 92. So that's an example of how you can do it. Let's take another number, say 156. So if we divide this by 2, you'll get 78. And then you divide that by 2 again, and you'll get 39. And then you'll divide that by 3, and you'll get 13. Right? So again, your prime numbers are here, 2, 2, 3, and a 13. So 156 is equal to 2 squared times 3 times 13. So that's my favorite way of doing it. There are a few other ways you can guess and check, essentially, using like smaller prime numbers, but this is probably the most visual way to do it. And in an exam, if you're ever asked to decompose a number, this is probably the best way to do it, because it'll probably be really easy for the marker to work out how you exactly did it, and you didn't just like randomly pick out some random numbers. Now, where do we use decomposition? So it's all good and well knowing how to do it, but we need to know where we can use it. So an example of this would be when it comes to LCMs, which stands for lowest common multiples, and HCF. So you may have come across these in primary schools. So the LCM of a number, of 2 numbers, or 3 numbers, is the lowest multiple that all 3 numbers have, or all the numbers have. So we'll take an example here. So say we have 3 and 3 is probably an easy number. Let's say 14 and 32. So the LCM of those 2 numbers. Now I picked myself a hard one here. So the way you do this is you get the prime decomposition of all these numbers. So the decomposition of 14 is 2 times 7, and the decomposition of 32 is 2 to the power of 5. So for the LCM, what you have to do is you have to get the highest power of each prime number from both numbers. So how we would do it in here, so 32 is equal to 2 to the power of 5, but just to make it easier for us to like visually see it, we can multiply this by 7 to the power of 0, which is equal to 1, so any number to the power of 0 is 1. And the reason I did that is because there's a 7 here, and so it's more visually easier to understand if we have a 7 on this side as well. So the highest power between the 2 numbers for the 2 is obviously this one over here, which is the 5, so it's 2 to the power of 5. Now the highest power for the 7s is obviously the one on the 14 here. So multiply that by 7. So what that should get you is 32 times 7. You can use a calculator for this, which is 224. So that's the LCM of 14 and 32. Now the highest common factor is similar, but it's a bit different. So if we do the same thing for 14 and 32, probably already know what that is. If we do, say, 36 and 42, so the prime decomposition of 36 would be 2 squared times 3 squared, and for 42 it would be 2 times 3 times 7. So the highest common factor, so for the LCM what we did was we took the highest power of each prime number. For the HCF we take the lowest power. So the lowest power of the 2's would be this one here. So that's 2 to the power of 1 multiplied. So the lowest power of these two, of the 3's, would be this one here again, times 3. And the lowest power of the 7's, so this one here on the 42 is 7 to the 1, but there's no 7's on the 36. So that means that it's 7 to the power of 0. And 0 is less than 1, so it's just 7 to the 0. So that's equal to 2 times 3, which is 6. So the HCF of 36 and 42 is 6. Now you might think that you often will get confused between which one you use for the LCM and the HCF, which one's the higher power, which one's the lower power. So the way I like to remember is obviously the multiple is always going to be either the same number or a larger number than the two numbers. So you need the most you can get out of each prime number, whereas the HCF, you want it to be lower than the number, so you need the lowest you can get. Well, that brings this video to an end, and I'd like to thank you all for watching this video. Please feel free to like and subscribe, and also comment any questions you may have. If you have any further questions or doubts that you'd like clearing up, please feel free to go onto the EduConnect website, which will be linked in the description, and sign up for one of our free plans, where I'll help you by using video calls to clear up any doubts you may have.